Muted.
Do you have any follow-up questions on the previous session? Yes? No questions? So let's start our discussion on NoSQL and okay, sure, Prem. Let me review your assignment. Okay. Any other questions? All right. No questions? Okay. So let's start our discussion on the NoSQL. Let me start the recording now. So, okay, you guys have already started the recording. All right, great. So So if you have no idea about SQL, you can say that you are expert at NoSQL. All right. Okay. So before we start with the rest of the discussion, we will quickly go over various terminologies, and then we will go into the details of HBase. Okay. So we'll start with simple understanding of NoSQL. All right. So what exactly is scale out and scale up? Okay. Scale out is also known as horizontal scaling, and scale up is also known as vertical scaling. Okay. In very simple words, if you had a cart and you have to carry a bigger load which a single horse cannot carry, if you replace a horse with an elephant, that's called vertical scaling. Okay. So for example, if you were running on a single 4 GB RAM, and then you realize that your server is not able to handle, you replace 4 GB with 16 gigabyte or 32 gigabyte RAM. That's called vertical scaling. Or maybe a better computer, better CPU, that's called vertical scaling. Now, if you replace one horse or you add one more horse to the cart, or you add more horses to the cart, that's called horizontal scaling. Meaning, if your one server was not able to handle the load, you added multiple servers. That's called horizontal scaling. Now, in case of, in the world of big data, the horizontal scaling is something preferred because vertical scaling has already been exhausted, and therefore vertical scaling is not solving the problem, and that's why we need horizontal scaling, because vertical scaling has got its limitations. For example, you cannot, let's say one single elephant could not handle the load, and the only way forward would be to get another cattle or another elephant to join in the cart. Okay, so because we cannot have a bigger elephant, or we cannot wait for elephant to grow bigger. Okay, so until you have bigger elephants, you will have to do away with the horizontal scaling. All right. So I hope this difference should be clear to everyone. Okay. So when you switch an elephant, so switch to multiple horses instead of going for elephant, meaning if you go for horizontal scaling, the cart has to be changed, the way you drive the cart, that has to be changed, and therefore the whole engineering is required. Okay, engineering as well as operations are required in order to horizontal scale, and that's the only reason the classes like this are playing its role, because now the systems have got changed, and they have become more horizontally scalable than the vertical one. Okay, so we will go into the details. Why did we need? We will show you this diagram. The first tendency is to go for an elephant, and then you realize that you can't do anything much, and then you go back to horizontal scaling. Okay, I'll show you this example. So this is the story. This is a classic story of 2000s, and most of you would be able to correlate with this story. So you have this initial public launch. You are working on a great e-commerce idea where you're going to have many more users buying lot of products and effectively having a great traffic. So this is a cool idea. So you have this initial public launch. You have moved the local workstations to a shared remotely hosted MySQL with a perfectly defined schema. So I'm going with the database side only right now, because application servers are also go through the similar life cycle. Generally, three-tier architecture. You basically have the web interface, I mean the UI, and the backend, which may be in Java, PHP, or Perl, Python, and the backend, which is in MySQL. Out of all of these, MySQL or the database, Oracle, or any of these systems, they suffer a lot. I mean, their load is highest because all of the heavy work like sorting, finding unique users, finding data for the users, and so on, all of that data and the data churning is delegated to the database. So database is generally the highest loaded item out of the whole stack when the load grows. So on the initial public launch, you moved your great perfect schema system into a public well-defined public server. So you have got the article in the news that your website is launched and everything. Now service is becoming popular. The next day you have many reads because there was an article, and there are too many reads hitting the database. Now at this point of time, even though your marketing people are very happy, but your development team realizes that it's becoming a challenge for the database. So What you do happily is that you add the memcache. What is memcache? It's a caching solution. What does it do? It basically brings the data from the database and keeps a copy of it if the data is being frequently read. If there is certain data which is being frequently read, it's kept in the cache. Okay, so the common queries are being served by cache now. Now, if you look at it closely, the moment you introduce a cache, what does it do? Your data is at two places, one at cache and other is at the MySQL. So most of the users are reading from the cache until the cache expires, and other people are writing to the database, and afterwards, when the writing is completed, cache is expired and built again. Now, if you notice here is the moment you introduce a layer like cache, the consistency is no longer there. Consistency is no longer there. Why? Because it takes time for change to propagate from database till the cache. You made a change in the DB. It will take some time to reach till the cache. Until that point of time, cache will be serving the older data. So even though at this point you won't realize that you have introduced inconsistency or you are no longer ACID. And who can tell me the meaning of ACID? Anybody? What are those ACID properties of a transaction of a database? Anyone? Yes, that's right, Lokesh. A for atomic. Atomicity. Yes, that's right, Yogesh. C for consistency. That's right, Ashwin and Ritika. I for, okay. So let me see who can tell. ACID, the full form of ACID, atomic, consistent, and what is the third property? I is not for integrity. Okay. Yes. Yes. Thank you, Prem. And thank you, Yogesh. Okay. So atomicity, consistency, isolation, and durability. Brilliant. Thank you, Prem and Yogesh. So yes, ACID properties are the properties of our relational databases, whereby a transaction have these properties, meaning whenever you make a change to the database, the change should be atomic, meaning either change happens completely or doesn't happen at all. So that's the first thing. Second is consistency. All the people who see the data just after the data has been confirmed as written or changed, afterwards all the readers should see the same data at the same time. All the readers should see the same data at the same time. This is a very important property. Third, the change of one person should not be impacted by the change of another. That's isolation. Okay. Third is durability, meaning if there was a change and database said, yes, I accept the change, it should be durable, meaning it should be saved in the disk. Even if database crashes, that particular change should remain. These are the guarantees of a transaction which a relational database provides. And the moment you bring in the caching layer, consistency is not there anymore. Okay, this is something which we all need to understand. Although most of us, including myself, most of us find caching one of the lowest hanging fruit when it comes to optimization, but caching introduces the read. Okay, now let's go ahead. Now, you're happy that you solved a good problem by caching, but that's not the end of it. As the service grows in popularity, there will be too many writes hitting the database. There are too many writes hitting the database, but lucky for you, you got some money and you bought really high-end server with great RAM, like 128 GB or 200 gigabytes of RAM, and you got a server with 16 cores and fastest hard disks possible in the industry. Okay, so your money went to maybe AWS. Half of the funding went for this. Now, okay, so you bought this kind of servers. If you could not afford it at this right point, the chances are that your servers will keep on crashing, your users will keep on going back, and you won't be any longer able to run the business. Okay, now good for you that you solved those problems, but at the same time as you raised the funding or you got some money to spend, you started hiring people, and they started building features, or you started adding more and more features. So take a typical case of Amazon's detail page. There are around 120 features on the detail page, and each feature means somebody is handling the title, somebody is handling the header, somebody is handling the handling the byline. Byline as in the author, name of the authors, that this product is by such and such. So somebody's handling that, and we are coming up newer ideas like you may also like these products, or the ideas like share with your friends. So you keep adding these complexities, or write the comments, write the reviews, give the stars, and you add like discussion on, people can ask questions, and so on. So every feature you add to your product would increase the complexity of the query, because the way classically we build features is we add more and more tables. We add more and more tables, and every table has a primary key which and there is a foreign key which relates to the basic database of the products, right? So now, as you see that whenever there will be a query getting all the details of a product, so it will be querying all these tables and then preparing the results. Now, when you have more features, which means more tables, and hence there will be too many joins, right? At this point of time, you realize that a single query that's being served is taking too much time to prepare. And at this point, the only way forward you think is to denormalize, meaning combine all these tables into a single table, okay, so that you don't have to join every time. And that's denormalization. That is a denormalization. Or if you are looking up for, say, ID in some other table, you will just take the full table detail and merge it. So that's denormalizing, the opposite of what you are taught at DBA school. At DBA school, the maximum amount of time goes in figuring out how can we normalize the database, right? So now, at this point of time, and as a matter of fact, I have actually done this activity in the same sequence, okay? And we did it for our internal customers at Asia. We had, because my query was joining around 80-90 tables, and it was 6-page query. So we denormalized the query so that there are fewer joins and the query runs faster. But so at this point of time, we have done two damages in order for optimization. For optimizations, we have gone out of track twice. One, denormalization. Other, losing the consistency. Next is rising popularity swamps the server. Still, even though you have got this great hardware, you have got denormalization in place, and you have got caching layer. If your company is really doing good, there will be rising popularity, and again, your server will be swamped. Okay, your server will be overloaded at this point as well. Now, things are still too slow, and so what you do is, next thing you do is you stop doing computations on the database side or any server-side computation. You try to delegate either to the middle layer, or you try to delegate these computations to the client side. Okay, you delegate all of this and try to minimize computations on the server side. Okay, computations could be that finding differences of the dates, converting a string into the dates, and converting it back into the another time zone, and so on. Or trying to convert the currency and all other kind of unnecessary computations. We delegate those to the client side, because on the client side, if you just give a big number representing the date, client can represent it in its own time zone, and you don't have to struggle on the back end. So afterwards, you realize that some queries are still too slow. And this is the truth. This is the truth. If you are a DBA and you have handled the load, you must have seen these all steps happening. Okay, specifically in e-commerce and anywhere there is a huge load on your services. So some queries are still too slow. So what you do is you periodically pre-materialize the most complex queries. Okay, so you start pre-materializing, meaning even before the customer had asked for something, we have pre-prepared it. Okay, and you try to stop joining in most cases, as we have told earlier. So at this point of time, reads would be okay, but writes will get slower and slower. Reads would be okay for a couple of reasons. One, we have uncomplicated the joins. Similarly, we have delegated the work to the client side. Third, we have delegated a lot of work to the cache and pre-materialized queries. All right. In these cases, the writes might go really slow. Okay. Now, what you do is something very dramatically crazy, which is you drop the secondary indexes. Because every time you build a column and people want to look up on that column, you would like to create an index on that. And this way, whenever you are adding more and more features and people are searching on those features or criteria, you will end up with lots of queries which are taking lots of time. Okay, and therefore you drop the secondary indexes, because every time you update a record, it takes the same amount of time as it takes to search, because you have to, while writing into a tree, because inside an index, it's nothing but a B tree. Okay, it's a sorted B tree, where when you write a data to the B tree, it takes similar amount of time as it takes to query. Therefore, since your writes are getting slower and slower, you drop the secondary indexes and instead build that kind of indexes inside your cache. And also, you do take one more step, that you remove the triggers. Okay, you remove the database triggers, instead build the triggers in the form of some kind of bus, data bus in the organization. Now the moment you do these kind of things, the DBAs would get really angry if they are they have not handled this amount of load. Okay. Now what you noticed here is, by the end of 7th step, we are no longer using any of the features of the database. We are not giving ACID properties. We don't have primary and foreign key relationship any longer because we have denormalized. We don't have indexes, secondary indexes, and the triggers. And if you ask a database guys, why should you pay them? They would say that they will make you count the list of these features. So effectively, due to load, you have to undo a lot of efforts. You have to, the whole economics or whole dynamics of building or engineering a web server have gone kaput. The whole change is so drastic, right? It's a dream of any DBA engineer that we write these great SQL queries with joining multiple tables and have a great schema, do the public key foreign key relationships and have triggers. But when the load hits your server, you take these steps because your purpose is not the database. Your purpose is to have great user experience. So whatever it takes you to achieve that user experience, you take those steps. And one of those steps as we've gone through this and this is what Amazon people also realize, that they don't need a database the way any other companies need. What they need actually is a data store. They don't need any of the excessive features which stops them from doing things fast. And that's where Amazon or the other companies came up with the idea of a data store or a NoSQL data store. And the first form of NoSQL data store was, anybody? What was the first popular form of NoSQL data store? Okay. All right. Kulbir's and Ashwini's question is, what is pre-materialize? Pre-materialize means pre-prepare the queries. Okay. Pre-prepare the queries as in, even if user don't need it right now, we will prepare all the things we know that user might ask. That is pre-materializing. Okay. And we do it periodically. All right. So the first data store was one done by Amazon. Okay. And so it was a classic key value pair. We will go into the details. It was a classic key value pair. They said that we don't need all of these relational databases. All we need is somewhere we can store our data. Somewhere where we can say that here is my name and retrieve it later on. All we needed was just a simple kind of a phone book, kind of a dictionary where there is a name and there is a value. Okay, so that was the first form of NoSQL. All right. So why NoSQL? The main reason is to handle huge data. Secondly, to handle the high availability. When there are millions of requests coming per minute, you should be able to handle those. Third, scale out. Meaning, today you are having thousands of requests per second. Tomorrow you might have hundreds of thousands of requests per second. Okay, so you should be gracefully add more machines without having to re-architect the whole thing. So these three reasons are the main reasons behind this kind of a database where we don't have too much of constraints, and we don't have too much of schema. It runs on commodity hardware. Since we are going with a distributed architecture. Okay, so to provide big data and high availability as well as scale out architecture, the only way is going with a distributed architecture. Okay, because scaling up is not the option. All right, and when you have a scale out architecture, the hardware has to be commodity. It should not be like $200,000 machine. It has to be more of $1,000 machine. Okay, so it should be more of $1,000 machine rather than $20,000 machine. Okay, so that's commodity hardware, and this is the reason why we need NoSQL. So when you have this kind of hardware and these kind of requirements, the traditional relational databases do not suffice. Okay, so in the same thing in different words. So what exactly is a NoSQL database? These are the new genre of data stores. They are not qualified to be called as database if you go with the definition of database in a traditional sense. So they are more like NoSQL data stores. So what is a NoSQL data store? Made to handle big data. And the primary reason they are able to handle big data is because they have distributed architecture, meaning the database runs on many computers instead of one. And there is an identifier for each record, and these are non-relational in nature in the sense that they don't provide ACID properties. They don't provide a foreign key primary key relationship. They are not normalized, and therefore they are not relational. These are open source because if there is a new kind of data store coming to the market, the only way it can get the adoption is by the way of open source. All right, it should be horizontally scalable, it should be schema free, and it should be able to manage huge data. And it should be able to run on commodity hardware, and there are around 150 NoSQL databases in the industry as of today. All right. Now these are the three broad categories, or four broad categories of NoSQL data stores. One is column-oriented or wide column databases. For example, Accumulo, Cassandra, and HBase. Those are the three databases that fall in the definition of column-oriented. We will go into something called column-oriented instead of row-oriented. Our traditional tables are row-oriented. We will differentiate between column-oriented and row-oriented soon. Next is document-oriented, meaning these databases store the data in the form of document, meaning a complex hierarchical structure. Document contains values, values contain other values, and so on. So document storage is very closely similar to an object data store. Okay, a document could be an XML document, a document could be JSON document, but most of the systems seem to prefer JSON document over the XML one. So for example, MongoDB and Couchbase both store the data in JSON object format. JSON as in JavaScript object notation. Okay, it's a very simple format where object is defined as something enclosed in key value pairs enclosed in curly brackets, and array is defined as something, a comma separated list of values inside square brackets. So that's how a JSON is defined. So MongoDB is one such example. So you can see that in the first case, the column-oriented database looks similar to a table. It has got one column, second column, third column, and fourth column. The only problem is that not all columns have values for all the rows. Document-oriented database, they are more like a complex structure. Like here, TV shows have seasons and episodes, and Episodes have reviews and cast members and so on. And third one, which is key value, is the most primitive and simplified data store. The Dynamo, which was from Amazon, was the key database in the history of NoSQLs because they started the chain reaction. Okay, they started this culture of NoSQL data stores. Okay, so Dynamo where key and value, where value is generally either binary object or a text object, and quite value is opaque to the system. So Dynamo, MemCacheDB, the one which we discussed earlier for caching layer, and Redis and Rike. So Redis is in-memory data store and so on. The fourth one is interesting. Fourth one is where you store the data in the form of graph. These are called graph-oriented data stores. Because in today's time, storing a graph has become a very important exercise when we talk about handling huge data from sources like Google Map or from Twitter or from Facebook. All right. A question from Prem. Document-oriented database will be slower than column-based. Not really, not really. There is no way to classify which one is slower than which one. All right? There is no correlation between the various data stores' speed. All right? A quick summary between the NoSQL versus SQL summary. We all know this. We have already discussed it. So most of the SQL databases are of one type, relational, while NoSQLs are of many types, as we discussed, 4 broad categories. So one was started in 1970s and other was 30 years later. The example of relational is MySQL, Postgres, Oracle, and other is MongoDB, Cassandra, HBase. In one case, the model is relational. In another case, it depends. Schemas, most of the relational database have predefined strong schemas, while in none of the NoSQLs, the schema is very loose and dynamic. In case of SQL databases, the scaling is vertical, while in the other case, it's horizontal. All right? Development model in case of SQL is mixed, but most of the NoSQLs are, almost every NoSQL is open source. SQL database supports transaction, that too with those 4 properties: atomicity, consistency, isolation, and durability. While in case of NoSQL, it all depends and it varies from data store to data store. Data manipulation in case of all relational is through SQL, which is structured query language, while in case of NoSQL, it varies from data store to data store. Consistency, consistency is strong in case of SQL databases, while in case of NoSQL, it depends on the product. All right? Now, there is something very interesting which comes into play. All right? So, we talked about how our system could not provide consistency, or how NoSQLs do not provide ACID properties, right? So the reasoning behind that is far more difficult than the obvious. and it was there is what do you say, a researcher named Eric Brewster. He says that out of consistency, availability, and partition tolerance, only two can be achieved, not all three. And it's not logically possible to achieve all three. And what does it mean by consistency? So while while designing a database or any database cannot guarantee all these three things, CAP, consistency, availability, and partition tolerance. Okay, so what is consistency? All the users or all the nodes see the same data at the same time, right? All the users should see the same data at the same time. Second is availability. A guarantee that every request receives a response. Every request receives a response. That's a guarantee. Third is partition tolerance. A system continues to operate despite arbitrary message loss. Okay, so these are the three properties, CAP, consistency, availability, and partition tolerance. These are the three properties which cannot be achieved at the same time. Okay, so are the definitions clear to everyone? So what is, okay, let me repeat what is partition tolerance. There is a question. So Yogesh is saying, does NoSQL DBs have capability of handling ACID properties? Quick answer is no. And the reasoning is CAP theorem. All right? Okay, so availability means the guarantee that every request receives a response, whether it was successful or failed. More number of requests, if you can answer, meaning your system has more availability. If your system cannot answer a few requests even, then your system is not highly available. Third is partition tolerance, meaning if a database goes down, can your system handle it? Okay, let me simplify it. Yes. So Ashwin's question is why it is not possible to achieve CAP theorem altogether. Okay, let's try to think through why it's not possible to achieve consistency, availability, and partition tolerance at the same time. Let's take a look at the various diagram. I thought about it and then I came up with this diagram, and probably this will answer your questions in the right manner. Let's take a look at the first system where there is one machine and there are many users, and all these users are writing and reading to the same machine. Now the data will be consistent because it's a single machine. It's taking users' data and it's keeping users in the queue for writing, right? Readers and writers are well in the queue, and it's managing all of that very well. Now question is it consistent? Yes. It is consistent because it's able to achieve all those four properties of transaction. Or you can say that all the users will see the same data at the same time, right? So the data will be consistent. But question is it highly available? How many users can it cater to? Answer is no, it's not highly available. It is limited by number of requests which are coming to one single machine, and readers and writers, since they are writing on the same line, while the writer finishes, reader will not be able to start, and hence there is a limitation on number of users accessing the database. Therefore, it's not highly available. There is no guarantee that all the requests that are coming to this machine would get answered. Most of them will time out. Third is partition tolerance. Is it partition tolerance? No. If this single machine goes down, none of the readers or writers will be able to read or write anything. So, the first system, this system is not partition tolerant. The system is not partition tolerant. Okay. Next is captive. In the next system, so this is the first example was our classic relational database. The second system is where you have two machines, A and B. All the writers are going to A while all the readers are reading from B. Or some of the readers could be reading from A, some of the readers are reading from B. Now there could be many B's, but there will be one single A because writer would be only one. If there are many servers writing the data or changing the data, what happens is complete chaos. If many machines simultaneously changing the same data, same record being modified by multiple machines, that's impossible to manage. Therefore, one of the architecture in case of distributed systems is single writer, one machine dedicated for writing, or one machine writing happens only through one machine while reading happens on the machine. Now what is wrong with this system? The system is not strongly consistent. Why? Why is this system, the second one, not strongly consistent? Writers are writing to A, the data is reaching B, and then readers are reading. There would be some time taken by the data to reach from A to B. It's like theory of relativity, where the time travel for speed, light, is also counted. Similarly here, the time taken from database A to B is counted, and therefore, by the time the change reaches to A, all the readers are reading still data, still something which has already changed. So the readers at B are still seeing the past, and therefore it's not strongly consistent. And that was the definition of consistent, right? All the users see the same data at the same time, right? The readers who are reading from A might be seeing the fresh data, but the readers reading from B would be seeing the older data. And therefore, the second system is not consistent. But good part is that since there are two machines, or there could be many B's, B1, B2, B3, B4, okay, who receives the changes. When you have many machines, you can scale to any level. Your database is fairly available with respect to readers. You can handle as many readers as you want, right? And therefore, the system is considered available. The third one is partition tolerance. What does it mean? If some of these machines die, if A dies, what happens to the data? Data is there with B. Now B might become the writer. Okay? So such kind of systems, MongoDB and Zookeeper, so are the example of such kind of system. MongoDB, Zookeeper, Cassandra. Cassandra. And this kind of systems are very much widely used. The third one is the kind of primary secondary kind of model, where if you remember our HDFS name node, there was name node and there was secondary name node, or you can say standby name node. Okay, so that's the third architecture, where all the users are reading from the first machine, and the first machine is pushing the data to a backup. Now, in this diagram, the data we get is consistent, but but it's not highly available. Also, is partition tolerance. If B dies or A dies, the process continues, nothing breaks. All right. So most of the systems, as you will see in the distributed architecture, would be a combination of these three diagrams. And these three diagrams proves that CAP are not possible together. Make sense to you? Was I able to explain these three diagrams and the properties? So one thing I forgot to tell you is something called eventually consistent. So since most of these systems were not able to provide consistency, they said that we will provide partial consistency and we'll call it eventually consistent, meaning since there is a single A, meaning all the writers are going to only one machine. All the writers are going to one machine. The data will be consistent. It's not consistent right now, but in long run or after some time, after a few minutes, everything is going to be all right. And that's what is called eventually the data is going to be consistent. So it's not consistent, but it's eventually consistent. All right? So this was the reason behind CAP theorem. I hope, is everybody with me? Did I make it overly complex? Yes, Ritika, Kulbir, Ellen, Ashwin, Prem, Ron, Lokesh, Yi Ming, Yi Meng, and Ravi, Ella, Ashwin, Katie, Finney, and Yogesh. Was he able to explain this diagram? Okay. So Ritika is saying that could you brief it again? I'll just go through it quickly. So basically, I was trying to explain why consistency, availability, and partition tolerance is not possible together. So what I did was I went through the general structure of most of the systems. The first one is our classic relational system, where all the readers and writers, meaning somebody who is running the update query and somebody who is running the select query, both go to the same database, right? So insert, update, select, and everything goes to the single server. In case this single server dies, there'll be nothing. Therefore, it's not partition tolerant. And since all the users are talking to single machine, therefore it's not available, but it is consistent because the database, since there is only one machine, it can maintain the queue of the users, and therefore it's consistent. Now, second one is where there are two machines, A and B. Writers are writing to A, and that data is being transmitted to all other machines, such as B. This replication is happening from A to B. So it takes time for data to reach from A to B, and that in that duration, the data that users reading from B see is stale. And hence, the same reasoning as caching, because it takes time to update cache, and during that time, the users will be reading older data. If somebody wrote some data and was talking to A, and instantaneously they run a select query and they are connected to B, and then they will see that this is disaster. I wrote something and I'm getting something else. And hence, it's not consistent, but it is eventually consistent. Since there are two machines, or there could be multiple machines, it is highly available, and it's partition tolerant. If some of these machines die, still this process will not stop. Okay? The third one is consistent. I mean, where the kind of name node and standby kind of model, where if there is only one machine which is taking the whole traffic and redirecting the traffic accordingly, but there is another machine which has exactly same copy of the data and can become and can take its take the place of A at any point of time, and therefore though it's consistent and partition tolerant, but not available because all the reading and writing is happening through A. Alan is saying lack of availability means some requests do not get a response of any kind. That's right. That's exactly it is. So the more number of requests can be served per second by your system, the more available is your machine. Okay, so that's a general definition of availability. It's not true and false. It's not that my system is not available at all. It is available, but it is not highly available. By increasing hardware or changing something, we won't be able to make relational database humongously available. All right? Now the next definition, the next terminology which is very much required as part of the theory is column-oriented database. Okay, it's a very common thing, and lots of people ask what is a column-oriented database, and this is very important to understand it, as you will see it further. And these definitions, whatever we are talking here, CAP theorem or column-oriented databases, these are widely applicable across all the NoSQL. Although we are only talking about HBase afterwards, but these ideas are going to be applicable in all. All right, now let's take a look at this table. To the user, this table looks really nice. It has got two columns and it has got three rows. It has got employee ID and name, and it has got three rows, 10 Joe, 12 Mary, 11 Kathy. Traditionally, be it CSV or be it relational databases, the way we stored it in the disk. What do we mean by serialization? Serialization is converting this file into sequence of letters or sequence of characters. So when you convert this data, traditionally, let's say we are converting this memory representation or the data structure into sequence of bytes, it would, when we serialize it, it would become like this. In the traditional row-oriented databases, record number, which is 0, the 1, right? Because every database keeps a record of row number. So we have 1, we store 10, after that we put comma and Joe, correct? This is how we store in CSV, this is how we store in database file internally. This is how internally it gets translated. 10 Joe, 12 Mary, and 11 Kathy. Do you see that? 10 Joe, 12 Mary, 11 Kathy. So the flow is more like, how should I say, something of this sort. So flow is more like you go from left to right and keep on storing it, right? That's how you store in a row-oriented database. 10 Joe, 12 Mary, 11 Kathy, correct? This is row-oriented data storage. Okay. So Ila's question is, does the row number has column name internally? No, it doesn't. All right. Now, some people realized that the column-oriented databases, if you save this data instead of going through row-wise, if we store it in if we store it this way, we first save this data and then we save this. Okay, we save this. So we save this way. We store 10, 12, 11, and then Joe, Mary, Kathy in the disk. The way we serialize. Okay, so some people said that if we do it this way, it will be more compact to store. Yogesh's question is, so that means entire string of a record is in the form of one column. So here internally the system knows that there are two columns. So here we have displayed comma, but most of the database has some unprintable character as the separator between the columns. So it knows that while reading and converting it into data structure, it would read from left to right, and it will break the records based on these unprintable characters, and then mark them that this is a 0th column, first column, this is 0th column, and first column, and so on. Make sense to you, Yogesh? All right. So some people found that when you store data in this way, like 10, 12, 11, Joe, Mary, Kathy, the data is far more compact. And can anybody reason? Can anybody tell why would it be compact? More compact than storing it row oriented? Anyone? The last question answer is few columns than rows, but the columns are same in both the cases. Interesting answers. Thank you, Ila. And all right. Alan's answer is, well, there are fewer terminal characters. Yeah, okay, that's something I did not notice. All right, so that's another two answers. Good. Any other? Yogesh says it's like key value. Yes. So it looks like key value, but yeah, it's more like CSV file. I've put it as if the serialized way, 010101 and so on. Okay. So when you save a CSV, the whole CSV is actually straight bytes, right? It's just that while loading, you split it by a new line and so on. CSV is in comma separated values. All right. So why is column oriented more compact? Now, if we have to compress same kind of values, it would be faster to compress. Imagine that instead of employee ID, we had age of employees as one of the columns, right? Now this age varies from, say, 0 to somewhere like 200 at max, right? So to represent age, you only need 200 bits, correct? You don't need 200 bits. You hardly need log to the base 2 of 200. Okay, so you need only few bytes to express the same kind of data. So the compression works great if there is a repetition in the data or there is a similarity in the data. All right? Yes, Ravi's point is that it's the same data type if it's column oriented. So while compression, if the data type is same as well as the values are same, the compression works great as compared to while compression, this value, then these values and so on. It becomes difficult. And therefore, it's not very obvious. It was not very obvious unless some researchers actually proved it over huge data. The savings of while compression were more than 20%. Therefore, column-oriented is a preferred way when we talk about NoSQL data storage. Okay, now going ahead. Now, databases like HBase, they said that we are not going to name ourselves as row-oriented or column-oriented. We will be rather more political. We'll make our system such that it's up to the user whether they wanted row-orientedness or column-orientedness. And that was the cleverest decision they took. That was a very clever decision they took. They made it column family oriented data store. Okay? Column family oriented data store. So you have two column families. The data in the column family gets stored together. Okay? Data in the column family gets stored together. All right? So we have two column families, CF1, CF2. There are employee IDs which are part of column family, name which is part of column family 1, and age is part of column family 2. Now in this case, this is a very interesting part. Okay, so here the way the data is stored is this. Okay, so the data in the column family is stored in the row-oriented manner, meaning 10 Joe, and then 12 Mary, 11 Kathy, and then from here 23, 33, and 45. Okay, so the data in column family gets stored together. Okay, the data in the column family gets stored together as in this. And then once this is done, then the data from column family 2 is stored. A last question is, in column families, row ID is its own column. Here you can say that every row has got an ID. All right. So here this will be stored as 01, which is the row number, 10, Joe, and Mary. Sorry, 10, Joe, and then 12, Mary, 11, Kathy, and afterward 23, 33, and 45. Make sense to you, Ella? So inside a column family, data is stored in the row-oriented manner, while column families are stored in the column-oriented manner. This will be clear now. Now, question is, if we have one column per column family, this is what kind of storage? Is it, which one is column oriented and which one is row oriented? Okay, there are two cases where in one case there is one column family per column, and there are one column family, and in the second case there is only one column family for all the columns. So this one is first one is a column oriented database or row oriented database. Anybody? Great. Prem's answer is that it is a column family oriented database. Why? Why is it column family? Because first CF1 will get stored, as I was explaining here, that first all the data in the CF1 will get stored, which means this data gets stored, and then the second one. Therefore, it's a column oriented, meaning column oriented as in the data gets stored like this. 10, 12, 11, Joy, Mary, Kathy. Okay, so similarly here, if you look at it, first this column family, then this column family, and then this column family, the data gets written or serialized in that manner. Did it make sense to you, Ashwin now? Yes, and the second table is, anybody? Second table is row oriented or column oriented? Yes, second table is row oriented. Why? Because it's a single column family, and inside a single column family the data is stored in a row oriented manner. Alright, so if you look at it closely, HBase, which is column family oriented, made sure that you can emulate both the behaviors as per your wish. Okay, do it make sense to you? So they said that, okay, we will make something called column families. If you put all the columns in a column family, then your database will become kind of row oriented. If you put one column in one column family, that means your data will become column oriented, right? So that was a very clever move. Okay, so Ila's question is, in the second example, if there was a second column family with 3 columns, then it would be column oriented. So we can't say it that way. I'll show you. So very good question actually. Let me just go over it again. So let's say there was one table like this, and let me just paste it here. Okay, so we have these two tables and a little bit move them. Good. Let's just move it a little bit. So we're talking about the second case. We have something of this sort. Okay. So here we have 2 column families. Some of the data, let's say we call it some age or some, say, company name, and then we call it something else. Let's call it salary. Okay, so these are the two column families. So the way data will get stored is in this manner. Okay, so first the first column family will get saved, which means 10 Joe, 23, 12 Mary, Kathy, and this. And after that, the second one will get stored. So the data of CF1 gets stored first, then CF2. Okay, so this is 1, this is 2. Make sense to you? Kulbir's question is, which is better for compression? Column-oriented databases are considered and found to be better at compression, and that's the only reason people use column-orientedness. Yes? Good. Let me clear up my slide. Okay. Makes sense to everybody is with me on this? Ila, Ashwin. A question from Prem. How to read column-oriented data? Can you please explain in this example? For the user, there is no difference. Okay? Whether it's column-oriented or row-oriented, it doesn't matter for the user. The reading API or writing API are not impacted. What is impacted is the optimization part. And why we are discussing this? Because as a database designer, sometimes you might have to take a call, what are the fields that would go in a single column family, and what are the fields that would go in some different column family. Next question from Ila is it right to say then if there are individual columns, then it is column oriented, and if there are column families, one or more, then it is record oriented. So here, this is basically not a column oriented database. It's a column family oriented database. Okay? In the classic case, when we are storing data in this manner, where there is no column family, then we can say it's column oriented or row oriented. Okay? It's just I'm giving an example on how can column family how can you structure pure column oriented or pure row oriented systems using column family. Make sense to you? All right. So we are trying to say that using column family, idea of column family, we can make our database behave like a column-oriented database or like a row-oriented database. All right. A question from Ravi. Can we call column family oriented ideas similar to partitions in RDBMS? It looks like a partition in RDBMS. Alright? I'll not take a strong analogy because not many things are similar. Okay. But yes, it looks like a column partitions in RDBMS. Alright. Now let's talk about HBase. So Ritika's question is, how do we decide in which way we want to place the data, the row-oriented way or column-oriented way? We will describe you as we go forward. Okay? So see, for the user, the table look the same. They will all read it like a row-oriented way. The classic way that there are rows, there are columns. Nothing is the difference for the end user. It's only for the serialization. It's an internal optimization. instead of storing data in the row-wise manner, internally the data is stored as column-wise. But it has no impact on the user's way of using it. It's just a great insight to know that the data is stored in this fashion, so can we take advantage of that optimization? We will go into those details. Alright, now let's talk about the HBase. HBase is CNP, meaning it's kind of the last architecture we discussed. It's kind of this architecture. Okay, it's consistent and partition tolerant, but is not highly available. Just like name node, HBase is also designed in the similar way. It's column family oriented database. It is based on Google's big table and is great for hundreds of millions or billions of rows. If your data is not in millions of records, don't use HBase. If your data is in 100,000 or below, then continue using your existing RDBMS. Okay, but if your data is going to go into millions or hundreds of millions of data, hundreds of millions of records, then you should be using HBase. Below hundreds of millions of records, your relational database can do a very good job. HBase is strongly consistent and not eventually. Okay, it's not eventually consistent. It's strongly consistent. Okay, so reads and writes are strongly consistent because there is a single machine in this diagram like this. It's a strongly consistent. It has automatic sharding. What is sharding? Dividing a big table into chunks and or dividing big table into smaller tables, some rows in one table, other rows in another, and so on. That's called sharding. And that was a classic technique to divide our work across multiple databases. For example, if you are running LinkedIn or let's say Yahoo case, some of the Yahoo Mail users went to one server based on their geography, and some of the Yahoo users went to another server based on their geography. Okay, so that was sharding. Division of the data based on certain criteria. Okay, so there becomes like independent island of the data. So similarly, in case of HBase, there is an internal sharding, division of the work on multiple machines, and these machines are called region servers. The way you have data nodes, here you have region server. The way you have name node in HDFS, here there are HBase master. Okay, so we'll go into the details now. And all of these region servers, which are supposed to store the actual table, they have the failover. Region servers do a failover. If in case one region server goes down, other one picks it up. And this is strong integration with HDFS. HBase, when it stores its data, it serializes and converts it into file. Instead of putting it directly on the machines, it puts it in HDFS. And it tries to make sure that the file, the first copy of the data remains on the region server part, and so HBase takes the advantage of high availability of region servers as well as data replication of HDFS. So HBase converts the rows records into a file and put that file into HDFS. Okay? Just like your Microsoft SQL server, when it stores its data file, it puts it in the local file system. HBase puts it in HDFS. All right. Now, to do the computation parallelly, it provides a way to do it using MapReduce. The API is available in Thrift as well as in Java. Okay, so API is available in Thrift as well in Java. What is Thrift? Thrift is a SOA layer, service-oriented layer, uh, and using Thrift, you can have a really fast communication. And Thrift is kind of de facto when it comes to service layer. All right, similar to triggers, the way you have relational database and there are triggers, HBase also provides you the triggers. And then for the indexing or searching, you have Bloom filters. Okay, so Ashwin's question is that what is a thrift? Okay, thrift is basically a service layer. All right, I'll try to describe it quickly. All right, so what is thrift? Let us say today you decide that you have built, let's say you have built a nice service like a phone directory. And this phone directory, people give it name and it gives them the phone number. Now let's say that you want to provide a client of this API. Okay, the first attempt you will do is provide a kind of URL based, HTTP based REST interface, but that might get complex after some time. And in case it goes complex, you may want to provide the API so that people using C#, Java, PHP, Python, or any other language, they should be able to use your phone directory, right? So you cannot humanly create the clients for all possible languages. And even if you were superhuman and you created the clients in every possible language, you will not be able to maintain those. And that's where thrift comes into picture. On thrift, you define that you want to provide these functions to your client, and thrift generates clients for all languages. The API, the kind of the API in their own language, C#, Java, PHP, Python, and Perl, and every kind of language, Thrift will prepare the API for you. And that's exactly the role of Thrift. So Thrift comes with two parts. One is Thrift server, which serves the data to the end who are calling API. Second, generation of the clients. It generates the client-side code, which gets bundled, and you can ship it to all your customers who can use that client-side library and make a call to your functions. Thrift is extremely fast and is kind of a de facto when it comes to serving a lot of API-based machinery. Okay, we used Thrift at InMobi exhaustively, and at even there was similar protocol at Amazon, which we modified some open source. Okay, so Thrift is done by Twitter, I think, and is being used by many people. A question from Ila. To clarify column family orientation, column family orientation is only for storing data, not a more efficient interface for SDFS. No, yes, that's right. Your understanding is right. Okay, so all right. Was he able to explain what is thrift? All right. Good, good. So this is a very architectural diagram of HBase. So HBase comes with somebody called master. Master is like name node. And you have region servers, many region server, and every region server has their internal file. This file gets stored on HDFS. And then it has some memory store, and it has a write-ahead log, as in when people are writing the data goes into write-ahead queue, and then when it gets finalized, data moves to H file and gets saved in HDFS. Okay, and on top of this, uh, we have HBase API layer. This API is written in Thrift. Okay, this API is written in Thrift, and users can call this API, and this API will talk to master and write to the region servers. Now, below you see here you have HDFS and Zookeeper. And what's HDFS here? So HDFS is our usual name node, data node. So master, while uh, delegating the request, it delegates to each region server, and this region server stores this file in HDFS, and while the user is asking for the data, it reads from HDFS and serves to the user. Now what is Zookeeper doing here? Zookeeper is a central kind of attendance system, you can call it attendance system, whereby all these region servers go and give its attendance to Zookeeper, and master comes and asks that who all is in the class, or who all has given you that attendance, and accordingly talks to those region servers. So this is a great way of coordination. We will talk about Zookeeper after some time. So the last question is H file on each data node or in the name node? It's basically, if you look at this here, if you look at this, for region server, HDFS is more like a single system. It doesn't matter to HBase whether the way you talk to HDFS saying, hey, here is my file, please store it. In the same way, region server is going to talk to HDFS. Internally, that whole magic of name node, data node would happen internally. But the client, like you, me, and the region servers have no control over that internal HDFS behavior, name node, data node, replication, and all that. Okay, so that is traditionally happening. That will happen, of course. All right. Yes. So that's a good question. So yes, that will happen internally, and this region server does not have a say in that. Ashwin's question is HBase master like name node? Yes. In the same diagram, again, I'm going back. So here, the example here is, you can say HBase master and name node with backup. All right. That's pretty much. Next question from Ashwin is, replication will be present in HBase local server and HDFS? No, replication will be in the HDFS only. Okay, just like the way when you upload a file in HDFS, similar way, HBase will be uploading its H files, as in region servers will be uploading its file in HDFS like a client. Okay. If it is so, then there will be more replication of a single file of yes, exactly the same reason. Therefore, HBase does not replicate anything. Great. All right, let's take a break for 10 minutes. Alright, so I'm back. Should we start now? Great. A question from Ella. Does HBase keep backup master H file? And yes. So backup master, yes, it has a provision to provide that, but yes, it can provide, you can have a backup of HBase master. All right. So this was a quick diagram of the architecture, and we will try to understand more about HBase and see how we can build, how we can model our data to fit into HBase. Okay. To understand the data modeling, we need to understand the limitations and the optimizations provided by a data storage. Okay. So first, the idea is, first idea is a reason. This reason is nothing but the table gets automatically partitioned horizontally into a region. Okay. All right. So how should I describe this? Let me try to describe this. Okay. Let me try to do that. Okay. So when you write into HBase, okay, you can think of this as a table. Okay. You define a table. It has got a header. It has got a header like this. Okay, maybe a column family, column name, and so on. So this is C1, C2, and C3. Okay. Now, as we saw here, there is master and there are many region servers. Okay. So when we have created a table, we have just defined maybe the columns or the table names. We will go into more details or how do you define the tables. There is no row, meaning no data. Therefore, there is no reason as of now. As we add first column, no, sorry, first row. This is our first row that we have just added into this table. This is the first row. Okay. Then we add another row. Okay, we have added some more data into this. Okay, and so this is a table. We are adding data into it. Initially, we will keep on adding more and more rows into this, and what will happen after some time? It will get splitted into the regions. After it reaches a certain size, it will split into two tables. Okay? After it reaches into, let's say now it is becoming big. So what would happen is that this table, this data will get separated into another region. Okay, another region. Let's say this is another region. Okay, and then users will start writing into first region and then second region. Okay, and they both will become bigger and bigger. So one table gets splitted into multiple regions. Initially, there is only one region. This was the first region. This was the only region earlier. Added more data into it. It got splitted into two, and then both of those regions started becoming bigger and bigger. Okay, so if you think carefully, it's like a big tree. When initially there is only one stem, then as it grows bigger, they become two stem, and then they become further, both of them can become two, and so on. That's how the tree keeps on growing further. Okay, so basically initially we start with one region. As the data starts overflowing, going beyond a certain size of the table is broken into two equal tables. Okay, and each of these tables, we call them a region. This is a one region, this is another region. Okay, and similarly, as we keep on growing bigger and bigger, these regions, when they cross again the boundaries, both of them will split, and further the same thing will keep on applying. Okay, a question, very good question from Ila. Question is, are the criteria for splitting determined by DBA? Yes. They specify, by default, there is a size of the file. The size can be changed by DBA, or they can even force splitting. Okay? Good. I hope this is clear. So tables are automatically partitioned into regions. Each region comprises of subset of table rows. A region is denoted by table it belongs to. So the way we define a child is that its parent, or its parent is this table, and the way we define region is that from this row ID to this row ID is going into this region, and from this region ID to this region ID, the data is going into second region. Okay? Yogesh's question is, splitting into region, do we have to define any column, or HBase will decide? We will define columns. We will define column families, and column families, and columns can be added on the fly. Okay, we'll show you this. Okay, so as the size of the region grows beyond the threshold, a region is broken, split, or split into two halves. Until the first is split, all the loading of the data is happening against a single region server or a single machine. As the table grows, number of its regions grow. All right? Now, there is a very important part about HBase tables. Every row in HBase table has a row ID. And that's true for every NoSQL database. Every NoSQL database, since the table or the data gets divided into multiple machines, every record has to be uniquely identifiable, and therefore the idea of rows comes into play. The idea of rows comes into play because the data gets divided into multiple machines. Similarly, in HBase, every row has to have a row key. So this is a row key, and these row key. So, and the table in HBase is ordered by row key. Table in HBase is ordered or sorted by the row key. All right. So rows are always ordered from A to Z or 0 to 9 and so on. It's binary ordering, 0, 1. And then, so First few records will go into first region server. Then, so this table will keep on getting splitted into these regions. You see, there are 6 regions in which the whole table is divided into. Some of these regions or sections are in uh, region 1, some are in region 2, region server 2, and some are in region server 3. There could be other tables and their regions could be co-located on the same region. Okay, this way our load on a table is shared by all the 3 regions, and when people query the data, all of the 3 region servers are consulted. Okay, based on, if somebody has defined a range that I'm going to look for all the data lesser than C, that means only the first region server will be queried. Alright, so this is how the data is segregated physically on region servers. So we have 3 region servers, and our table has these row keys or row IDs, and let's say they are going from A to till Z, just like a dictionary. So some of the records are in 1, 2, 3. You can think of one big dictionary cut into 3 regions. Some sections are on this, some are on another, and another. Okay, so this way we have clear that, and these are not, we have not shuffled, the pages are ordered still. Okay, so all the record, so that we don't have to remember exactly where did our record go. So HBase master only has to remember that the range here, you see, since a region is ordered by the row key, we just have to know that what does each region represent, the starting row and ending row key. Okay, starting row key and ending row key. All right. All right. So here a question from Ritika. Region servers are data node. So region servers are independent services. They are not really data nodes. Okay. They can be co-located as data node on the same machine, but they are different services altogether. A question from Ila. This may be a confusing question. Can data from 2 separate tables reside on the same region server? Yes, it can. My assumption is key are only unique per table, so separate tables have separate keys, of course, but a region is defined by the parent table. So a region also knows its table. So the keys are not clashing with another table. A question from Kulbir. What if one region server goes down? Very interesting question. And the answer is in the question asked by Yogesh. Very interesting questions. These questions deserve answers. All right, brilliant question. So first question is, what if one region server goes down? Second is, storage of region server data also resides in the HDFS. Yes. So the data for each region server is in HDFS. So in case one region server goes down, we know that which section of the data was in which region server, so we can load it again. Okay, we can load the data again on another region server. and therefore we can uh, easily we can easily bounce back the lost region server. Make sense to you? Great questions. Next question from Alan is, why is it necessary to split at all if underlying data is in HDFS? Can somebody answer this question? It's a very good question. Yes. All right. Before that, let me answer quickly Ravi's question. Loading back is done automatically? Yes. Now, Kulbir's question is, how do we know what section of the data region server is where uh, in the metadata? Yes, the HBase master has that. Okay, Lokesh's answer to Alan's question is quicker reads. Okay, and my answer is quicker writes. All right, good, good, great. So why do we need to split if the underlying data is HDFS? HDFS is great if all you have to do is append to the existing data. The problem with HDFS is when you want to alter the data, and that too, and altering the data is very difficult in any of the file systems. File systems allow you a great way of serially reading the data and serially writing the data. But if you have to change the second character, or you have to insert one word in third line of a text file, you have to rewrite whole file. And that's a challenge. And that's why these sections are created, and that's why the idea of a record, idea of a row comes into play, because every row you can add it independently. Okay, every row you can add it independently. You leave paddings internally when data stores, the way they are designed is that every record has got certain padding, and that padding can accommodate a lot of changes. And as the so those kind of ideas make up these reasons and the other data stores. Do I make sense to you? So now, so I established the fact that why do we need record based, and your question further, let me try to bring your question again, that why is it necessary to split at all if underlying data is in HDFS? The problem is that when you deal with really big table like 100 million rows, and you want to edit the blocks, it's not really possible so easily. Second, we want to distribute the load on a file. Let's say there are 1 million readers of a file. What we want to do is, instead of reading the whole file, we want to direct them to only those region servers which contain the data they demand. So the data in HDFS is just for rollback? No. Data in HDFS is for actual storage. So every region file is stored, file of every region is stored in HDFS. I think I confused everyone. All right. Okay. Alan, did I confuse you? So let's take a look at this diagram. I think this will be better to explain with this. Let's say there is one reason, second, third, fourth, first. There are 6 reasons. If a user is coming to look for a key that is starting with A, will redirect to region server 1 and then region server 2 and so on. Now, the data here can be modified by the users, and similar is true for inserting. Imagine that there was only one single table. Now, when the request comes in, this single machine is busy in figuring out how to read the data, and that's why the load has to be shared. Okay, let me answer Alan's question further and try my best. So Alan's further question is, I'm confused about the difference between data in the region server and the data in the HDFS. So this file which each region server stores, this goes as a separate file in HDFS. So there will be 6 separate files sitting in HDFS. Or there could be more than 6 if each region server is stored as separate file. I'll show you this and then things will be clear. Good? Difference between data on the region server and the data in HDFS. So there will be 6 files, one for each region in the HDFS. No, so Yogesh's question is it like logical split? Yes. This is record-wise. It won't happen that half of the record or half of the row is in one region and half of the row is another. So this physical split is basically complete row, not like half of the row, just like in HDFS where it doesn't care about any boundaries. The splitting is very raw. Okay. Now let me try to understand Ila's question. Ela's question is, so to clarify my understanding, when data is loaded in HBase, after successful write, it is automatically saved in HDFS? Yes, I'll just change here loaded into saved. Okay, saved in HDFS. Second question is, is there any algorithm in HBase to load the data on data nodes where region servers may reside? So HBase does not interact with the data nodes. HBase interact with HDFS the way me and you interact with HDFS, and HBase tries not to fiddle with the internals of HDFS. All right. So the algorithm does not try to optimize any of the ways of data node behaviors. Okay. Maybe it might be basically utilizing whatever services or whatever things are provided by HDFS, such as appending to the file and overwriting the blocks in a more efficient manner. Okay. Now, Alan's further question is, so inserts are done to the region server and then HTML file is overwritten. That's correct. Okay, so the inserts are done to the region server and the HDFS file is overwritten. The difference between the two, so on one end the inserts are being happening on region server and the data is flowing to HDFS to be overwritten, and the something that stands between the two is called write ahead log. Okay, that's a standard way of it's basically a kind of a queue. So I'll try to display it using a good analogy. So imagine there is a big pipe and there are small chunks of small data is being written continuously into this pipe. So the writes are happening from one end. The user is writing the data to the pipe, and on the other end, when you are, ouch, I can think of it this way. Alright, so the data is looking like this. Okay, so on another end, the somebody who is consuming it, like overwriting the file, and like this. Okay, so it will take a lot of packets in a single shot, lot of changes, and then merge them and then write it in a single shot. Okay, because for it to save bigger data is okay. Alright, so this way from here it will be taken and saved into a file. So this is called a write ahead. This is called a write ahead log. Okay, so if this log is this size of this pipe is very small, and this write ahead log is actually a file. We will show you this part as well. Okay, no worries. Now a question from Ila. Very good questions actually. Keep the questions coming. This is the only way to understand the process. Okay, because these ideas of write ahead log and everything are quite common across most of the data systems, and it's very important to understand these. Okay, a system might become obsolete. Maybe tomorrow HBase might become obsolete, but the ideas like column oriented, cap theorem, and the way region server is being splitted, these ideas will remain and will be used in another databases. That's why I am a little bit more focused towards the ideas behind structuring system. Okay, so another question from Ila. What determines the number of regions in a region server? Okay, so size of region server is fixed. Okay, maximum size of a region server is fixed. Okay, and number of region server is also kind of based on how many machines you have, right? Now the total size of a file divided by max size of a region is equal to number of regions, right? That's number of regions. Correct, because the whole file will be broken down into regions, and in case there is a, so this is minimum number of regions. There could be a little bit more. Now these region servers, if these region servers are regions are more than region servers, therefore there will be two reasons on each. There will be more than one reason on each region server. Okay. So as regions will keep on growing and there are no more region servers available, these regions will keep on moving into various region servers. So what is determining number of regions in a region server? The total size of a file. Total size of a file. Make sense to you? I have a question from Yogesh as well. Let me pick that. Question from Yogesh is, so if user wants the data in a particular region to be looked for a query, will pull the entire data of that region from HDFS. Yes. If a user wants data, let's say here, you're looking for data starting with Q. So HBase master will talk to region server. Region server which one? LMNOPQ. This one, right? MNOPQ. This one. This region will contain the Q, right? So this region will be consulted and then only that particular file from the region is consulted. We'll go into the details. Actually, there will be one file per column family. Okay, so it will be far more smaller than that. What you're thinking. Okay, so it will not be per region there will be a file. There will be per region there will be a folder, and inside that folder there will be a file. You will understand it very well as we go into. If I show you the data, then you will understand more. A question from Kulbir. If I update one record in HBase which is mapped to only one block in HDFS, then only one block of that file will be written. Yes, that's how you can see the benefit of HBase. So that's exactly the reason behind breaking the whole file into. All right, good, very great questions. Keep the questions coming. If the region server goes down, some of those commits will be lost. Yes. Actually, the interesting part is, yes and no. Interesting part is the commits are in the form of what do you call it? The journal. Okay, meaning it's append only. Appended into HDFS file. So as in when new changes are coming, they keep on appending into the HDFS file, and periodically, so this Q, what you see here is actually, where did it go? Oh, it's deleted. Okay, so this Q that I drew earlier, that was actually in a HDFS file. So the changes will not be lost. All right, I hope, okay. A question from Ella. Okay, there's no dumb question. Every question has a reasoning behind it. If it's very obvious, maybe I did not explain something well. Now question is, updates will occur for all replicates. All replicates, yes, that's a good question. So yes, this is an answer to this one. Here the question was that if only one block of a file is over, what is that? No, sorry. I answered it wrong way. I'm extremely sorry for this. Yes, this one I'm really sorry. If I update one record in HBase which is mapped to only one file. So one block, no. Actually, there is no mapping between HBase record and the file. Okay, there is no mapping of HBase record and the blocks. The mapping is between HBase record and HDFS file. You will see that. And so the whole file is rewritten. You will see that. So the whole file will be rewritten. Whole file will be rewritten. Maybe I might have to, and all the replications would happen. Okay, so I will have to basically, maybe I'll have to reconfirm. This I'm very sure so far. Maybe HBase has done some kind of tweaking with HDFS internal, but I'm of quite 90% sure. Okay, that it doesn't go to the block level. Right? I don't think HBase interacts on the block level. It interacts on the file level with HDFS. Okay. Now the data model part. I hope I've answered everyone's question. Okay. All right. This is something very important. This definition of data model comes from the big table, because HBase was kind of followed line by line on the paper called Big Table by Google. And the definition of Big Table was probably the most crisp definition I've ever come across. That paper is by Sanjay Gamawat and Jeff Dean. And the definition was like single line, and that is like precise definition of the data model. Okay, the way when people ask me what is a hash table, I tell them it's a collection of key value pairs. Okay, and when they say what does it mean by a sorted hash table, I tell them that the keys in a hash table, when you retrieve them, say key set from a hash table, they're ordered. They are not just random bag. Similarly, in case of a big table, the way they define, or HBase is defined in, it's a sparse, distributed, persistent, multi-dimensional sorted map. Let's go from right to left. It's a map. It's a collection of key value pair. And what kind of map? It's sorted, meaning the data is ordered by the key, and it's multidimensional, meaning the values contains the dimensions further. So the values contain column, and there is a key for every value. Now let's go further. It's persistent, meaning any change you make to this map is like key value pair collection, any change you make to this map is saved in the database. Okay, and it's distributed, meaning this map is broken down into multiple machines. Some keys are on one machine along with their value, some other keys are on another machine, right? And then sparse, meaning there is no guarantee that all the records of this map will have same dimension as the other one, right? All the records are not supposed to have the same dimension. Dimension meaning number of columns. So some has some column, other have some other column, and so on. So it is a sorted map, meaning map is key value collection. Map is, you can say that in a phone directory, name value pair. So sorted map is a phone directory or a dictionary where you have key and where you have value and ordered by the name. And so multidimensional, meaning the value contains columns. Okay, value is having dimensions. Okay, it could have X, Y, Z, and something. Persistent, whenever you make a change, it is persisted, it does not get lost. Okay? Distributed meaning it is distributed on many machines. Sparse meaning, what does it mean by sparse? Sparse means the columns on one row could be totally different from another, and therefore the table could have millions of columns while only 1% of the whole table is full. 99% of the table is empty. That's why it's called sparse table. Alright, so now let's try to understand it further. Do I make sense here? Okay. A question from Ella before I go further. One question, can we filter data on HBase before sending to HDFS? Maybe I have some data for later. If yes, then how do I keep my entire data in HBase with backups? So whatever data you put in HBase, it internally pushes it to HDFS. And if you try to access these files, they are more or less useless for you. Okay? So the best way to interact with that data is via HBase. So while storing the data in HBase itself, you filter the data. Okay? So whenever you want to deal with certain data in the form of a map, in the form of a table, then you use HBase. And when you want to modify the data continuously, in those cases you use HBase. Otherwise, you continue with your HDFS if the data is only append only. All right. Let's say there is the server which is generating the logs continuously. In those cases, using HBase is completely okay. Sorry, not using HDFS is completely okay if you're generating logs continuously, but if certain users are coming, they're updating some data, in those cases, HBase is better than HDFS. All right. Ila's question is, can you give use cases best for HBase? Whenever you have to access a humongous data, let's say you have millions of sensors sending the data continuously, and this data is being updated, or this data is updating or modifying values somewhere. In those cases, HBase is great. Okay, HBase was designed to keep track of page rank and the worldwide data. HBase was designed because keeping track of page rank of every page or who is referring who became impossible. And that's why HBase was designed that cool. I mean, Bigtable was designed for that. Who is referring who? All right. Next is that the primary idea inside Bigtable or HBase is a table. A table is nothing but a usual table. It's a top level namespace separation between my work and your work. HBase organizes data into tables. Table names have to be strings because there will be a folder created in HBase with the same name as table name. Alright, so it has to be clean. Alright, you can't have slashes, colons in the table names. Now, within a table, Within a table, data is stored according to its row key, or every table contains rows and every row has a row key. Yeah? Every row is identified by a row key. Row keys do not have data types. Okay? Unlike relational databases, row keys do not have data types. They are binary data. Okay? So that's why it makes a little bit more painful to read from HBase in a classic sense. So row keys do not have data types. They are treated more like a binary data or byte array, which means, interestingly, which means row key can store a movie file. And I have done that. I was amazed at, it was very irritating in the beginning when I came to know that the row key could contain anything. And when we realized that we could actually use row key for storing a huge data as a movie file, okay, which we would have never imagined otherwise. Okay, and it was a very good design. When we thought about it later, we found that it was a very good design by putting this big binary data into the row key. All right. All right. Next is column family. Since we talked about earlier that a column family, this table data is divided by column families. So data within a row is grouped by column family. It impacts the physical arrangement of data, and they must be defined upfront and are not easily modifiable. Okay, so when you are creating a table, the only thing HBase asks you, it, only thing it asks you is give me the column family name that you're going to keep, because you cannot insert the data in a table without telling that it is in this column family. All right. Although the hue interface allows you to modify the column family, but generally it's considered too much of work because it will delete the table, create a fresh one, create the column family. Every row in a table has the same column families, but it's not needed that every column family contains a column. Okay, so a row need not store data in all the column families, and just like table name, column families, name of the column family has to be file system safe. Why? Again, it's going to create a folder with the name, a file with the name as column family. Okay. All right. All right. Now, next question. Okay. So then comes the column qualifier. So at the top there is table. Table contains rows. Rows have column families, and column families contain columns. All right. So every column has got a name, and columns can be dynamically added. And actually, in the way you design an HBase table, you actually add columns dynamically. You don't need to define columns at all. You don't define the columns of a table. You only define column family in the beginning. And like row keys, you can put the any data inside column name. And then comes the cell. Cell means cell is the one storage of data. So you can store data in column key's name. You can store data in row key, and you can store data in a cell. All right. So you say so a cell is you can look at it that way. Inside a table, inside a row, inside a row key, inside a column family, inside a column, and there is the cell. Cell could have versions. By default, cell has 3 versions. You can define any other version you want. By default, the criteria for versioning is a timestamp, but you could define, instead of saying V1, V2, V3, you could say something else. So values within a cell are versioned, and the version number, which is by default the timestamp at the time which was written, if you don't specify the the version number which you want to read, the latest value is returned. The number of versions returned by HBase is configured for each column family. These versions are quite useful to resolve the conflict between multiple clients accessing the same cell at the same time. Okay. All right. I'd like to spend a little bit more time. So Ashwin's question is, how a row contains column family? This is how. So you can see that for this row, there are 2 column family, this and that. Okay? Or you can also say the reverse. All right? And what does it mean? You can add anything in the column name, meaning the column name actually can contain not only plain English text, but also binary data. You can upload a blob into the column name. Blob is big, large object. Make sense to you? All right. So this is how you can see in a nice way, our classic way, the way we have been looking at the database. This is a table in HBase. Every row has got a row key. It has got 2 column families, personal and office. Inside personal, you have name and residence phone number. In office, you have phone and address. How cell versioning is stored inside. So here, internally, it is stored in the file itself, and there are multiple versions of each value. Is that the question, you guys? That how the cell versioning is stored inside? Basically here, every cell there are 3 values. It's array of 3 by default, and then it's stored in at the same place where it stores the cell value. Ela's question is, will every update create another record? No, it won't create. It basically, for a cell, it will overwrite the previous cell value and create the current value, and hence that's how it will keep. Okay. So only the cell value, whenever you're updating it, you just keep the previous value. But if there are only 3 versions you're keeping, and you're making 20 updates to the same cell value, only last 3 will be kept. All right? Makes sense to you? Yoges's question is, will we be able to retrieve previous value of the cell? Yes. And even while storing, if you don't like the timestamp as the criteria for the cell value, you could specify some other criteria of your own choice. Alright? So that gives you a way of resolving conflict between multiple writers. That's one use case of cell values. Ashwin's question is, here row key is stored in HBase master and column family is stored in HDFS. Yes, you can think of it that way. Alright? Because master needs to track which rows went to which one. So generally, master does not store the row key actually. Master just keeps in mind the range. It just keeps in mind the range of the key. All the keys starting from 1 to 6 are in this. So master only keep the range of keys, range of row keys, meaning from A till C. These are the two variables. Instead of keeping the track of every variable, we'll just keep the track of ranges. Because every region is sorted by the key. There are no overlapping ranges of row keys amongst two regions. Make sense to you, Ashwin? Ritika's question is, how do you generate the row key? Good. And further question is, what is the naming convention to come up with a column family name? Okay. So first question, let me just, these are very good questions. Okay. Yeah. First question from Ritika is, how do you generate the keys? Okay. And actually this question also need to be kept here. These are very good questions. Yes. Here the row key is, so only the key ranges, relation between key range and region ID. Okay? Region ID stored on HBase master. Okay? So HBase master stores these values. Otherwise, if there are billions of keys, then HBase master will overflow. That's why it only stores the regions. And why doesn't it need to store every key? Because every region is ordered by key. So therefore you know for sure that all the data between these two endpoints is going to be in the same region. Therefore, you don't need to keep track of every region ID. Okay, next question is, what is the naming convention to come up? Okay, next, okay. Here, how do you generate the row key? It will be your call and it will be up to you. How do you generate the row key? You could use many techniques like random number generation, or there are many other like UUID from Java, and similar methods are there in Python. You can use those to generate the row key if you don't have a criteria. Generally, people have a clear criteria to generate a unique row key. Okay? And what is the naming convention to come up with the column family? So all the data that you want together, okay, should be in a same family. And why would you want together? If your access pattern of a certain data is like such as that you want all of that data always accessible. Whenever you access first name, you also access last name. Okay? And whenever you're accessing first name, last name, you always access phone number. So you generally would keep first name, last name, and the phone number in the same column family. Very good set of questions. A question from Ella. If update is not a new record, then data is updated, then does it get the previous version? Yes. You can access the cell's versioning because every time you, yes, in that sense, if you are thinking in the cell's strict sense, whenever we are adding the data, whenever we are updating a cell, the previous value is preserved and we can access the previous value. So you can think of it as if that we have added a new cell value and previously the older than the 3 we have removed. Okay, so you can yeah. So you are partly right that whenever we are adding a new value, it's updating a new value, it's actually adding a value and deleting the oldest one. All right. Good, great set of questions. All right. The other way to look at the same table is the row ID, then the column family, then the column name, and timestamp and the value, timestamp and the value, and the another column family, another column and the timestamp. These are the versions of the same cell value. Yes, Ritika, did I miss your question? All right. So this is how you can look. Now let's take a case study. And this case study is about the reason why big table was invented in first place, or HBase, the whole architecture was created. So this case study is from Google and why they use or how they use HBase or big table to store data. Okay? Now here there are few things to note. It's essentially data from all the web pages from the globe. It contains a row. The row key is the domain name. Row key is the domain name, or you can say row key is a URL. All right, and it has got two column family. One is called contents, other is called anchor. Okay, so contents contain one column with a blank name. Column can be a blank name. We said column could be anything, so column could be blank. So here, but anchor contains all the people who are referring to this website. So anchor cnsi.com contains this value, meaning what is the hyperlink text? Okay, how cnnsi.com is referring to cnn.com. For a time being, let's just here there is one more thing. Important thing is they have reversed the URL. Instead of saying www.cnn.com, the way they have stored the row key is com.cnn.ww. So the row key is the URL. There are two column family. One is contents, meaning the raw content from the page. Okay, and second is anchor text. Anchor is another column family, okay, and contains two columns. One cnnsi.com, another mylook.ca. Okay, and the cell value is the text. So cnn.com is being referred by cnnsi.com as CNN, and cnn.com is referred by mylook.ca as cnn.com. Okay, so this way we know when we look at this table, we can clearly tell what are the contents of this particular URL and who all across the globe is referring it. So now you can see that this table would have 100 billions of columns, okay, and it will have 100 billions of rows. Okay, whenever Google Crawler will encounter a new website, it will add a row here, and then after it has finished parsing that data, it will figure out which all other websites are being referred by this particular crawler. Sorry, by this particular newly created page. Okay, so all right. So whenever a Google crawler goes to a website, a fresh new website, it creates a row here. Row ID is the reverse of the URL which has been crawled. Contents column, blank column, the first column contains the actual content it has found, and then maybe there is a secondary process running in the background which picks up this HTML, parses it, and then updates all other pages, all other rows which are being referred by newly created, newly downloaded page. Okay, newly downloaded page. Make sense to you? Is everybody with me on this? So let me just try to, how can I create new slide, new document, new spreadsheet. All right, so let's say this is our big table. Let's call it crawl corpus. Okay, this is a crawl corpus. Okay, yeah, this is a crawl corpus of the whole World Wide Web. So let's say we first encountered a website called Microsoft.com. Okay, now this website is is having some HTML containing welcome to Microsoft and so on. Okay, now it's not being referred by anybody as such. So contents column is the column name, and this is the row key. And the way it has stored it is com.microsoft. I will come back to it, why it is being referred like that. Now, let us say that there is another website called, say, Hortonworks. Okay, Hortonworks is saying HTML and then say href equals Microsoft.com. I'm assuming that you are comfortable with the HTML. Okay, so even if you're not, don't worry. So here we are Hortonworks is giving an href to Microsoft, saying that what do you call, let's say Microsoft. Okay, now this is just crawler just downloaded this new record, so it made an entry here, and parallelly the parsing of this data started. Now there it noticed that Hortonworks.com is referring to Microsoft as Microsoft, right? Or let's say it says MSFT. Okay, so now crawler will go and find all the records, find the record where href Microsoft is found. So this is the one. Okay, and here it will create a column called anchor colon Hortonworks.com, okay, is referring it as MSFT. Alright, similarly, if it had a href equals apache.org, and it says that it's Apache license. There is another website referred by it is Apache license. Here it'll go here. It'll say A colon, not A. It'll say org.apache, and then it'll have no content right now. It'll just say that Hortonworks is referring org.apache in the same column, anchor Hortonworks. In the same column, it will say Apache license. Do I make sense to you? All right. So we are just creating as we download org.apache and we realize that Apache is referring Hortonworks again, hortonworks.com. We call it, say, Hadoop implementer. Okay, that's how Apache.org is referring to Hortonworks. Here, what would happen is it'll go back when it downloads org.apache, it goes to here and creates one more column called anchor colon org apache.org, and there it writes Hadoop implementer. Okay. So here what you see is it's a table that contains two things. One, the actual raw content of the website. Second, who is referring to who with what name. So that once Google has this data, it can clearly prepare the PageRank graph. Okay, so it might be having one more column saying, let's say PageRank. Okay, rank some. Okay, let's say computed, and we call it PageRank. So here it has generated some rank 5, 4, or say 4.5. Now. And then based on who else is referring, this rank will be updated, and accordingly the cycle of rank computation will carry on. Alright. So our last question is, did we define third column or it was dynamically created? It keeps on created. The most important thing you need to understand is, in case of table, in case of HBase, the way you add rows into the table, in the same way you can add columns. Okay? Rows are separated into regions while columns are separated into column families. So when you add rows, they are added and the way you have row key, which is the header defining the header based on which you can search the row, in the same way you can define the column header. So column has a header, row has a header, row can be added dynamically, column can be added dynamically, and your row could be billions and column could be billions. Okay, so HBase's behavior towards row and columns is quite symmetric. Do I make sense to you? Is everybody with me? Because it took me some time to understand why it was created. And when, for the first time when I was doing the HDFS, okay, when I was doing the, not HDFS, I was doing the Cassandra. And Cassandra has the same structure. It took me some time that why do we need to, why do we have to worry about what goes in the column value? It took me some time to digest the fact that columns could be added dynamically. And instead of having that mental block, because I come from a relational database background, and I think almost all of us come from that background, whenever we think about adding more columns, we get scared. We don't add columns, we add rows. Okay, so column families we define upfront. Here there are two column family, anchor and contents, but we can keep on adding as many as columns as we want. All right, did I say something wrong earlier, Ella? Did I say that column families can be added as and when we want? Columns can be added, but column family remain. These two column families, content and anchor, will remain. All right. Now, there's one thing that has been pending. Why did we reverse this URL? Can somebody tell why did we reverse this URL, or why did Google reverse this URL? Anyone? Yes. Yes, that's right. So, right. So why did we? Yes, thank you, Lokesh. That's good. So, yes, the reason we had done the reverse is so that kind of it becomes that we bring data for each domain together. Okay, so if you look at it, com.microsoft.ww, com.microsoft.mail, and com.microsoft.m. Similarly for Google, okay, this will come before. So if data is stored for these domains in this order, because the data is ordered by the key. So if these are the keys, the data will be ordered in this manner. So I will sort it in a minute. What do you call it? Okay, so I'll show you. So, or we can have play. So the data, if we sort this data by just like this. Okay, so you can see that clearly if we find the key called com.google in the region, then we can simply keep on reading next, 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 okay, and we'll get all the subdomains of Google together. Similarly, if you want to find out all the websites of Microsoft, all the subdomains of Microsoft, we could simply do this. We could simply search first for com.microsoft and then go to next record, next record, next record, and we'll read all of the records of Microsoft. So the data is ordered by the key, and we have made sure that that ordering helps us to bring all the subdomains of a domain together. Make sense to you? And there's the reasoning behind keeping that as a key. Now, that also teaches us that we'll have to exploit this feature of HBase to keep the data which we want together. Okay? So there are two kind of grouping. First, based on the row key. Second, based on the column family. Third, column names. Okay? Column names. So these are the ways of reorganizing and structuring your data in HBase. All right? So This is something, okay. Alright, let me just repeat what we have talked till now. One is indexing is based on row key. Tables are sorted based on the row key. Each region of a table has sorted row key space, and therefore saying therefore identifying each region by start and end key is sufficient. Okay. Also keep in mind that the way we define region is this way. Okay. The end key is not included while start key is included. It means this region contains all the keys starting with the start key but up before end key. Everything in HBase table is stored as binary array. Atomicity is guaranteed only at row level, not at multi-row level. There is no transaction called multi-row transaction in HBase. But luckily, whole row we can do atomic transaction on the whole row. Atomic as in either the whole row will change or nothing will change. It won't happen that change in the first cell reflected while other did not. Okay, column families have to be defined upfront. Column qualifiers are dynamic and can be defined at right time. They are stored as binary byte array, so you can store anything in the cell, column name, and the row key. You can't store anything. You can only store plain text strings in the table name and column family name. So whenever we are querying this table, whenever we are saying give me a particular row key or row key ranges, we get row key, column family, column qualifier, and timestamp in this manner. Let's try to say quick hello. Lokesh's question is it not too expensive? Which part are you talking about, Lokesh? You mean the indexing? Yes, just the row. So these are the few things. Yeah. So indexing is based just on the row, right? That's what you wanted to say, or just the row-based transaction. Yeah. So yes. So just the row-based transaction has been done in a way that since if we try to give a transaction over multi-row, we'll end up with a relational database, and the performance will drastically die down, and hence it has tried to keep the transaction based on the row. Alright, let's try to say quick hello. Alright, and I'm going to go to console, although you can do from the UI as well. You can do it from the UI. Alright, let me just copy paste the values. Okay, so here if I say HBase shell, I'll get this. Similarly, let me also open Hue. In Hue, if you go into Hive or HBase, okay. So you can see that there are many tables here, and you could create your own table. You could define your own table. This is my table, and I could define a column family. Let's say CF1. Okay, somebody has already created, so I need to be more, let's say, crawl corpus. Okay, column family is contents, and other one was max version is 3. That's okay. So per column family we could define the number of versions. Then we can say anchor, and that's it. Cannot convert argument to integer. Which argument does it want to create? These are the column families. Okay. Column name. Maximum versions must be positive. What happened to this guy? Ah, it wanted me to type that. Is it creating or doing something else? And last question is, what time are we ending? We'll be ending in like 20 minutes from now. Wow. Finally it got created. So we have crawl corpus here. There are no columns as of now. But when we create new row, it asks for row key. And let's call it com.microsoft. Okay. And we say, what column family do we want? We will say contents, and cell value is HTML. And then we say anchor, and it refers to, say, what do you call? Windows.com. So we have added this, and so on. Alright, so this way is the UI way. Similarly, we could go to the shell called HBase shell, and there we could create the table. We will first check what's the status. We'll just check what's the status. 2 servers, 2 dead, which means there are 2 machines which are down. We can't check that, but that's okay. It can handle all of these kind of scenarios very well. So I'm going to create the table quickly. We'll call it mytable9apr, and let me bring it to another window. Okay, good. It says the table has been created. Alright, so I could go to home, and I could also say list. There are these many tables, and I can say scan, or let's say, let me just go down to, so I could also say things like give me all the tables which are starting with which contain table in them. So there is a 9 April table. So I could, let me replace my table with 9 April table. Okay. So I'm going to put this 1, 2, 3, 4, which is the cell value, in row 2 and this column family. Okay. So it has updated it. Similarly, in another row, row 1, I'm adding one column. So what I do, I say in this table, for this row, in this column, put this. And the way we define column is column family name and column name. Now you can see the data. You can see in row 1, this is the data. In row 2, this is the data. All right. If you want to specifically request the value in this table, where is the value? Okay, my CF column value row 1. Row 1, my CF column value 1. Right now it's empty because there is no value in there. If you say 2, then you'll get the value. Now, you can also check the status of a table saying these are the details. And if you want to drop this table, you can disable it and delete it. Okay, we will disable and delete it later. All right. The other way is if you basically can take a look at this table clearly here. Okay. All right. That was one thing. Next is where is this data? By default, it creates this HDFS file for every table inside this folder. Okay, let's go and check it. So I'll just go to File and added this, copy paste that folder. Here we have. So you can see that for every table, be it this one, there is a file, there is a folder created for every table. And what was the table which we created? We created something to do with 9 April. Good. You can see that. Clear this. Now you can see inside this table, there is one big number. This is what? This is the reason ID. If there were many records in this and there were 2 reasons created, there will be 2 folders, one for each. So this reason is created automatically. And you see this recovered edits? This contains that temporary data. Okay? So inside this big number which represent the reason ID, inside this reason we have a folder for this column family. There is one column family that contains this data. Okay? And as and when we put more data, the data will move into this table. And also, the description of this table is also mentioned in here. Okay? All the details about table is created in HDFS. So that this metadata does not take up, there is always a backup copy of the metadata, although this metadata is also available in memory, but still. So few things are clear. Let me also add some more data into this. And is there a way to flush a table? Can I flush my table 9 APR? Okay, so when I flush, all the temporary data is most likely is going to be moved into the column family. You can see that? Now this is very important. So here there is a table. Table is a folder name. Inside that there is a reason, and then there is a column family. Inside the column family is your row ID. Okay, this is the row ID. I'm sorry. This is a table, column family. Sorry, table, reason ID, then the column family, and then then afterwards this is the call. This is the, just a second. So yeah, table, reason, column family. Okay, this is the store file automatically generated. This name is automatically generated. Okay, so this is the store file number. There will be, for each column family, there would be many such files. All right. So we inserted some data here. So and this data you see is in the binary format, so you can't see much. The only thing you can see is 1, 2, 3, 4 here. Do you see that? The one which we inserted there. And there will be some more ways of locating more data. It will be difficult. So this is all padding. As I was saying, that every file is padded so that you could edit it. And here there is a so yeah, this is 1, 2, 3, 4, fine. There is 1, 2, 3, 4, yeah. So column family 2 and column family 1. Okay. So basically this underlying structure I'm trying to show you, you will not have to interact with any of this. You will be interacting directly with HDFS just to prove the point that HDFS is being used in the back end of HBase. Okay? That's why I'm showing you this. Alright? The way the data is stored is in the form of data block format, and it's not really readable for us. So a question from Yogesh. Store files are per record. Not really. Store files are per what do you call, column family. All right. So this was all right. Now this we have already talked about. So Ila's point is that, sorry, getting confused here. So what others are also having questions at this point. Please let me know exact questions. I'll try my best to answer. So what I was trying to show you is that even though we are dealing with HBase, underlying it's actually storing data in a binary format in the HDFS. All right. Next question is, row updates are automatic. All right. This we have already discussed. Okay. So few things here. One, HBase inherently does not provide you any query language. It provides a very basic one. Give me the value for this particular key, row key, and so on. Give me the value for all the keys from this to that. Those kind of API, very, very rudimentary APIs, are provided by HBase. But people have developed the query engines around HBase. You can try those. All right. So the most simple way of accessing data in HBase is using scanners. And scanners are like a traditional databases cursors. You have to close them after use. And scanners return rows in the order of the row key. So the way, if you are using Java, you can use result scanner rs equals to htable.getScanner. And you will pass the scan parameters in the scanner. Okay, and what is scan parameter? It says that from what row key to what row key do you want, and what are the columns that you're expecting in the output, and you may want to run a filter that needs to be run on the server side, and this filter will decide which rows should be in the output. And every invocation of next will trip back to the region server and give you the next set of records. Alright? So the way we created a table from console, in the same way you could create table using Java clients. And the good news is that this client, this API, although it looks ugly, but it is embraced, it is being embraced by Google as well. So this API is quite useful in that sense, that as of today, if people have to query the big table of Google, they'll use the similar API. So you create a config object. So you create a config object, and then you create an admin handle. This is admin handle. This admin handle will create everything. Then you define a table description, create a table descriptor. Then you create a column and column family descriptor, and then you create a table using this table descriptor, and so on. And then you can query the database for tables in using this admin handle. You can say admin list tables, and it'll give you all the list of tables and so on. Okay, so those who are interested in Java API, take a look at the Java API. That will be quite useful to you. And next is that you could create MapReduce program for HBase. Okay, you could basically create MapReduce program in the same way as we have created for running using HDFS. Okay, so when you create a mapper, by default the data that you receive is from a table. So this mapper code will run against every row of a table, and then you will get that row in an argument for the map, and then you can process it, and then you can put the key value pairs in the context. And similarly, you could create a reducer where for every key you generated in the mapper, all the values will be brought together, and you will put the data in the context. And the output of this reducer will go into the another table. Okay, so the MapReduce on HBase takes input from a HBase table and gives output to the HBase table. Okay, and you can stitch in the same way, the way we stitched our driver code. You see that we have config, then create the job, then you define a scan parameter defining from what range to what range you want to input the data from a table into map. And then you can create a map job and reduce job and wait for the job completion, and then exit from it. Alright, so that's one way. Now I would like to discuss I'm extremely sorry, actually I was supposed to finish at 11. Alright, I just forgot that. Alright, so that's pretty much, and actually I okay, even Ella reminded me, because my other previous class was running at 8:30 to 11:30, so I actually totally forgot that the class will finish at 11:30. A question from Ella, will we be able to complete this by then? No, we will have at least 3 more sessions. Okay, 3 more sessions still. Alright. Alright, so we will discuss Bloom filter tomorrow. and then that should be it. And then go through the Spark and other components. All right. All right. Thank you very much, and have a great day ahead. Bye-bye. All right.